All right, everybody, welcome to the video here for lesson number 4, solving equations with rational expressions. So this is the first of 2 lessons dealing with this concept, and these would be what I would consider the easier ones, only because there's less algebra involved at the beginning and also less algebra at the end. So a couple things to notice that's different from when you solved these when you were, I don't know, way back in elementary school, middle school, whenever you did this. I'm not even sure you started to do them with easy denominators like 2 and 3. We want to look for something called extraneous solutions. Extraneous is just the fancy math word for saying solutions that don't check. So what we know right away with looking at a question with all the work we've done so far is we know what the value of the variable can't be before I start solving it. For example, for number 1, I know the value of x cannot be 2. So if I solve and I get 2 for my answer, I know that that doesn't work. Now these first 2 are kind of pretty basic, straightforward questions. They are just cross multiplication. So I'm going to get 4x minus 8 is equal to 4x minus 8. And this is something that came up in Algebra 1. We didn't talk about this in class, so I was hoping that you noticed this in the homework and remembered it from Algebra 1. If you get something on the left-hand side of an equation that's equivalent to the same exact thing on the other side of the equation, that means there's an infinite number of solutions that make this work. So I can say x can be all real numbers except 2. That's actually my answer there. For number 2, if you cross multiply here again, so I'm going to get 4x minus 8 is equal to 3x minus 6. This one actually is solvable. So if I move the 3x to the other side and the 8 to the other, I get x equals 2. Well, 2 we know would make this undefined, so that's rejected. It's what we call our extraneous solution. So we could actually say x has no solution. So an empty set of brackets, or you could write no solution or use the symbol of the 0 with the slash horizontally through it. Number 3, looking for a greatest, not a greatest, common denominator. We want to make the common denominator here 2b squared. So for that first fraction, I want to make it 2b squared. I want to multiply the numerator by 2. So that's going to become 2b squared minus 2b minus 12. To make the second fraction have a denominator of 2b squared, I'd have to multiply the top there by 2b. So that'll become 4b squared plus 24b. Notice this subtraction sign is going to distribute to both of those. We'll talk about that later. And the last fraction has 2b, but I want 2b squared, so I'd have to multiply by b. So that'll become b squared minus 39b. Also, before I move any further, notice I can't have 0 as a value of b. It would make it undefined. So if I get 0 as an answer, we know it's wrong. So if I do some distributing here, and now I don't need the denominators anymore, my equation becomes 2b squared minus 2b minus 12 minus 4b squared minus 24b equals b squared minus 39b. Notice I'm distributing the negative. Combine up all your like terms here. So I have negative 2b squared. I have negative 26b. I have a negative 12. And I still have b squared minus 39b. I want to make it so that my b squared is positive. So I'm going to move everything from the left-hand side to the right-hand side. So I'm going to get 0 equals 3b squared. If I add 26 to negative 39, I'm going to get negative 13b plus 12. Factor. So to factor this, I need to figure out, well, what multiplies to make positive 36, but adds to make negative 13? Negative 9 and negative 4. So now I could split this up using that AC method. So if we split this up using the AC method, I get 0 equals 3b squared minus 9b minus 4b plus 12. GCF of the first two terms is 3b, leaving you with b minus 3. Negative 4, leaving you with b minus 3. And you wind up getting the two factors here of 3b minus 4 and b minus 3. Therefore, b is equal to the solution of 4/3 and positive 3. Both of those are good because neither of them make the denominator undefined. Let's move on to the next one. So the next one, the common denominator here is going to become 6x plus 3, x plus 2. So to make that in that first fraction, 6x plus 3, x plus 2, I have to multiply the numerator by 6. It already has x plus 3. It also has to have the x plus 2. Second fraction, again, to make it 6x plus 3, x plus 2, I'm going to multiply the 6 again. This time the x plus 3, and then what was already there, the x minus 5. And for the last fraction, I have the 6, x plus 3, x plus 2. Well, I'm going to have 17, x plus 3, and x plus 2. Lots of multiplying here. Now, luckily, the numerators are the only thing that matters at this point. So if I multiply out here at the beginning, and I'm just going to use a different color here so you could see what I'm doing. So x plus 2, x plus 1, we're so good at factoring now, we know that's going to become that expression, right? The 2 and the 1 add to 3 and then multiply to make 2. Same thing's going to happen here. So I have x squared minus 2x minus 15. And at the end, I'm going to get x squared plus 5x plus 6. Now, what I just did in red, you should really be able to do with mental math. If you can't, make your boxes and multiply it all out. That's perfectly fine too. So what are we going to get here if we start distributing the 6's? So if I distribute the 6 to what's in red up here, I'm going to get 6x squared plus 18x plus 12. If I distribute the negative 6, don't forget the negative, I'm going to get negative 6x squared plus 12x and another plus, so that's going to be 90. No. Yeah. And on the other side, I'm going to get 17x squared plus 17 times 5. So that's what, 85x plus 102. And then we start combining up some like terms. Luckily for us, these 6x squareds cancel. 18 and 12 makes 30. 12 and 90 makes 102. On the other side, I have 17x squared plus 85x plus 102. If I start moving terms to the other side, so subtract 30 and subtract 102, I wind up having 0 equals 17x squared plus plus 55x. The 102's cancel to nothing. So then you might be saying, well, how the heck do I factor that? Well, it's just GCF, right? So we're trying to figure out, well, is there a common factor there between 17 and 55? So since 17's prime, I would just divide 55 by 17 and see that it doesn't work. But I can factor out an x. leaving us with 17x plus 55. So I get x equals negative 55 over 17 and 0. Nothing we can't do there. Let's go on the next page. Couple left. Number 5, notice the first two fractions are exactly the same. The last one is what's different. Now, the first two fractions have this denominator of m times m plus 1. It's just not shown that way because it's not factored. So by factoring it, it should help me easily identify that this last fraction, well, it's just missing the m. So if I multiply that to the top, I get m squared minus 6m. Distribute that negative, get rid of the denominators, and I have m plus 5 is equal to 1 minus m squared plus 6m. I don't want a negative m squared, so I'm going to move that all to the left. So I'm going to get m squared. If I subtract 6m, I get negative 5m. If I subtract 1, I get plus 4, all equals 0. Do some factoring. M minus 4, m minus 1. So that gives me m equals 4 and m equals 1, both of which check. So my solution here is just m equals 1 and 4. For the last one, I see my common denominator is going to become y times y plus 2. So the first fraction I'm going to multiply by y, so that's going to give me 4y all over y times y plus 2. The second fraction is 1, so I'm just going to put the same thing over itself to make it so that I have this common denominator. And the last fraction has everything I want, so I'll just leave it. Now that my denominators are all the same, I don't care about them anymore. So I'm left with the equation 4y equals y squared plus 2y minus 8. Move the 4y to the other side. I get y squared minus 2y minus 8, and do my factoring. Y minus 4, y plus 2. So I get y equals 4, which checks, and y equals negative 2, which is rejected because it would make this fraction undefined. So my only answer here is y equals 4. Number 7. Number 7, I'm trying to create a common denominator here, which would be x times x minus 1. So the first fraction I'm going to multiply by x. Second fraction I'm going to multiply by x minus 1. The last fraction I'm going to multiply by both. And it's still equal to 0. 0 is not going to change anything, so even if I multiply it by something, it's going to still be 0. So I'm left with the equation 4x plus 3x minus 3 minus 3x squared plus 3x all equals 0. Combined up like terms, move stuff around. What can we do here, right? So I wind up having 10x's. So I'm going to get a 3x squared minus 10x plus 3 equals 0 if I move all my terms around. So I'm just moving the 3x to the other side. I'm taking the 10x, also moving it to the other side, and the negative 3 moving to the other side to make it so that the negative 3x squared becomes positive. Factor. Well, multiplies to make 9, but adds to make negative 10. Well, that would be negative 9 and negative 1. So this is again going to be that AC method. 3x squared minus 9x minus x plus 3. GCF of the first two terms is 3x, leaving me with an x minus 3. Negative 1 with an x minus 3. This one actually wasn't too bad. So then we have 3x minus 1 and x minus 3 as my two factors. So my two answers are going to be 1/3 and 3. Neither of those make an undefined value, so we're all good. Number 8 says create and solve a rational equation that has 2 as an extraneous solution. there's about a million different ones, actually an infinite number of equations that work. So if you tried this one and it works out and you think that it's a good one, you could show me and we'll check it out, and maybe I'll even make it one of the test questions. We'll see. All right. So hopefully this video helped. Keep going along and doing your homework assignments will be all good. If you're watching this video, I'm probably going to check the homework before the next lesson. I haven't checked it in a few days, so just keep that in mind. All right, and good luck.